Welcome to video T.1C, an application of reflections to minimize distance. This is the classic problem, every math teacher loves it. All right, so example 3. A trail designer is planning 2 trails that connect campsites A and B to a point somewhere on the river. Okay? He wants the total length of the trails to be as short as possible, minimize the resources needed. Where should the trails meet at the river? Here, 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 etc. Okay, so something to keep in mind is the shortest distance between 3 points is a straight line. So if I could somehow get a straight line scenario out of this, that's going to be the key. And reflections is going to be the key to that. So what you want to do is reflect either point A or point B about the river. It makes no difference. I'll just choose to reflect point B. Okay, so again, to reflect a point, what you want to do is go perpendicular, do your helper line, and go that far beyond. So I'll start with my helper line. Again, making my ruler marked line up that's parallel there. And I'll just draw it as such. Make sure that you go at least that distance beyond. Then what you want to do is use your ruler to measure the distance from that point to the line of reflection. On your piece of paper, it'll end up being 1.6 centimeters. Okay, so if it's 1.6 centimeters there, you want to make it be 1.6 centimeters there as well. So I'll just use a different color. And now I've got to measure this with my ruler. Okay, so we've got that. Going to be right there. So that is also 1.6 centimeters. And I'll just call that point B prime. So all I did is I reflected a point. Then, here's the fun part, connect the other campsite to that reflection. And then, I've got a saying in compass construction, X marks the spot. Okay, so that is going to be the answer to the problem. So I'll just circle it. So that's where you want the paths to meet. And just to give you a little background on that, if I connected this over here, let's take a quick look at what's happening here. This triangle is basically being reflected to this triangle. So that means this is congruent to this. Oh, okay. So, hey, this distance here and this distance here are the same. I love having this distance here because now I've got that straight line scenario between A, X, and B. So by reflecting one of them, generated that straight line distance, and now it's minimized. I measured on my paper. If I put X there, AX is 2.8, BX is 2.1, so the whole distance is 4.9. Again, 2.8 here, 2.1 there, 2.1 there. Okay, just for the heck of it, I did another scenario. I'll do it in red. I said, hey, what if you just dropped straight down here and called that point Y and had that be the point where you go to? And then you'd have this be the other path. You might say, oh, well, that's the shortest distance from A to the river. I agree, but then it's a longer distance from B. I did the calculations, and AY was 2.2, BY was 3.6, so the total distance was 5.8. Okay, so that's definitely not the way to do it. So again, X is my answer. I just wanted to show you another scenario. So there you have it, how to use reflections to solve a real-world application.